Welcome to the final video for polynomials. The last video ended with talking about what end behavior was. We're going to start this video by being able to predict the end behavior for any polynomial. The first thing you're going to want to know to predict end behavior is it an even degree or an odd degree polynomial? We talked about last time, if you have an even degree polynomial, your arrows will head in the same direction. So x squared, arrows head in the same direction. X to the fourth, arrows head in the same direction. They either both go up or they both go down. So when you have a positive leading coefficient, for example, 3x squared plus 4, I have a positive 3 out front. That means my arrows are going to end going up. If you have a negative leading coefficient, so if you have a negative 5x to the fourth minus x plus 2, there is a negative in front of the term with the largest exponent. So negative leading coefficients means that your arrows are going to end going down. Now, actually writing your end behavior, you're going to make your positive infinities and negative infinities first all over the graph to help you. And then we're going to read what the graph is saying. So, as x goes to positive infinity, positive x values are on the right of the graph. So look to the right of the graph. And on the right, we said that we are heading up. So I'm going to put up to positive infinity, or just infinity if you would like it. Doesn't make a difference. The next one, as x goes to negative infinity, negative x values are on the left. So you're going to say, on the left of my graph, over here, my graph's still going up. So I'm going to put f of x goes to infinity. For the next one, when you have a negative leading coefficient, as x goes to infinity, which is on the right, your graph goes down on the right. So you're going to put negative infinity. As x goes to negative infinity, negative x values are on the left, your graph goes down again. So you're going to head to negative infinity. Please be careful and make sure you carefully read how they set up the end behavior if they give it to you. Again, as x goes to infinity does not need to come first. They can start with as x goes to negative infinity. So just keep that in mind and read carefully. When you have an odd degree, your arrows are going to head in opposite directions. If you have a positive leading coefficient, so again, we have a 4x cubed plus 2. So my leading coefficient is positive 4. You're going to start from the bottom and go up, right? And you're going to end heading up. Overall, this graph is going upwards because there's a positive leading coefficient. If you have a function with a negative leading coefficient, negative 2x to the fifth plus x, there's a negative out front. That means you're going to start from the top and go down. So your arrow on the right should be down below. To write out the end behaviors, fill out your graph. And then try to do these on your own, pause the video, and then check your answers. Again, this is saying as x goes to the right, look at what your graph is doing. Your graph is heading up on the right, so you're going to put it, f of x goes to infinity because your y values are going up. As x goes to negative infinity on the left, your graph is heading down, so you're going to put negative infinity. As x goes to positive infinity on the right, by the way, you do not have to write right and left each time. I'm writing that to help you out. So as we go to the right, your graph is heading down towards negative infinity. As x goes to negative infinity, negative x values on the left. So on the left, your graph is heading up. So you're going to put positive infinity. So let's try actually practicing. Does this have an even degree or an odd degree? Your arrows are heading in opposite directions, right? One's going down, one's going up, so that would be an odd degree. Is it positive or a negative leading coefficient? That's what LC stands for. You're going to say it's positive because you end going up. Overall, this graph goes up. The next one, because your arrows both end going up, you have that it is a even degree polynomial. Specifically, because they are going up, it is a positive leading coefficient. Your arrows are heading in the same direction, so it is even. They're both heading down, so you have a negative in front of this equation to make all of your y values negative. One arrow's going up, one arrow's going down, so it's an odd degree because they're heading in opposite directions. And because overall this graph is heading down, you are ending going down, it is a negative leading coefficient. So now look at the following example. They want you to figure out what degree it is. You're going to look for the largest exponent because it's not necessarily out front. And in this case, my largest exponent is 4. So I have a degree of 4. Is the exponent even or odd? It's even. That means my arrows are going to either head both up or both down. Basically, I have this as an option or that as an option. The graph's not going to look like a parabola. I just mean to show you the arrows are both going up or the arrows are both going down. The sign of your leading coefficient. Your leading coefficient is a positive 2. So it is a positive. If you have a positive leading coefficient, that means this is what you're going to have. Both arrows are going to be going up. So predict its end behavior. As x goes to infinity, those are positive x values, and positive x values are on the right. Your y values, f of x, is going to go up to positive infinity. As x goes to negative infinity, which is on the left, that's where your negative x values are. Your y values on the left of the graph are going to be going up as well. So positive infinity. All of this is your answer, and remember, you do have to remember how to express and behavior on your own. So these two pieces of information you have to remember. Those two pieces will be the same every time, and you just need to fill out the red. This problem is telling you to predict the end behavior of the function, and obviously you can just put it in the calculator and see what the end behavior is going to be. But let's try it doing it by hand without looking at the calculator. So to find the end behavior, you need the degree and the leading coefficient. So my degree of this example My largest exponent is a 3. So my degree is 3. That means it is odd. So my arrows are going in opposite directions. I'm either starting from the bottom and going up, or I'm starting from the top and going down. Now you're going to look at your leading coefficient, the LC. My leading coefficient is a negative 3. So I'm going to say that this is negative. And that means I'm going to end going down. Now you can use that to write your end behavior. So end behavior you're going to start with, because you're going to remember this, as x goes to infinity, what does f of x do? And as x goes to negative infinity, what does f of x do? Again, if you wrote the negative infinity up top and the positive infinity down below, it's good. Either way works. So as x goes to infinity, that means we're talking about the right towards positive x values. And on the right of this graph, I'm going to head down because of that negative leading coefficient. So I'm going to head towards negative infinity. As x goes to negative infinity, negative x values are on the left. And on the left of this graph, my y values are going up. So I'm going to say that f of x, the y values, heads to positive infinity. This whole thing is your answer, and you have to write it like this specifically or you will lose points on the regions. And that's all for polynomials.